Expectation and variance. Expectation of a discrete random variable. If we have a statistical experiment, example, throwing an unbiased die 120 times and record the results. A. A practical approach results in a frequency distribution and a mean value. From this frequency distribution table, as shown, the score against the frequency, the mean score is x bar, which is equals to summation of the frequency times the score over the summation of the frequency, and that will give you 3.56. B. A theoretical approach results in a probability distribution and an expected value or expected mean. Now, suppose we toss an unbiased die and x is the number on the die. Then, the probability distribution of x is as shown. Score 1, the probability is 1/6, 2, 1/6, 3, also 1/6, 4, 1/6, 5, 1/6, 6, 1/6. Therefore, the expectation of x, or the expected value, is the score times the probability, and summing them, you end up with 7/2, which is comparable to the practical approach. Note, if Ex is a constant, not a function of x. 2. Ex represents the average score that is expected to be obtained if a sufficiently large number of the same experiment were repeated under the same set of conditions. Variance and standard deviation. While expectation is a measurement of central tendency, that is, it attempts to locate a typical value about which the distribution clusters, variance is a measure of dispersion. Variance measures the spread of a set of observations, that is, how scattered a distribution is. It is defined as the average of the squared deviations from the mean. Standard deviation is simply the positive square root of the variance, that is, standard deviation is equals to the square root of the variance. Expectation and variance of the binomial random variable. If the random variable x is such that x follows a binomial NP, then the expectation Ex equals to NP, and the variance of x equals to NP 1 minus P, or I can say that it is equals to 1 equals to NPQ. Note, the formula Lee's MF15 refers to expectation as the mean. By running a simulation of binomial experiment, we can see that expectation is the average in the long run. Let us look at example 8. If on average 2 out of 5 days are sunny, find the expected number of sunny days in a week and the standard deviation. Let us define the random variable. Let x be the random variable, which is the number of sunny days in a week. From the question, n is 7, the probability of a sunny day, it is 2 out of 5, which is 0.4. Q is 1 minus P, which is 0.6. So, we can define x follows a binomial, 7, 0.4. Expectation of the binomial is NP, which is equals to 7 times 0.4, and that will give you 2.8. The variance is NPQ, or NP 1 minus P. By substituting n as 7, P as 0.4, 1 minus P as 0.6, you end up with 1.68. Standard deviation will be the square root of the variance, which is 1.3. Example 9. The random variable x is binomially distributed with parameters n and p. Given that expectation Ex is 2 and variance of x equals to 24/13, find the values of n and p. Since x follows a binomial np, and the expectation for binomial ex equals to np, which is 2 given, and the variance of x, which is equals to np 1 minus p, equals to 24 over 13. By solving simultaneously and substituting np to be 2 into the variance, you end up with 1 minus p equals to 12 over 13. Therefore, p equals to 1 over 13. Once you have found p, you can find n, which is 2 times 13, and that will give you 26. Example 10. A pottery produces Royal Souvenir marks. It's noted that 6% are defective. If 20 marks are selected at random, find the probability that the sample contains less than 5 defective marks and the most likely or most probable number of defective marks. Let x be the random variable, the number of defective marks in a sample of 20. N is 20, p is 0.06. Therefore, x follows a binomial 20, 0.06. The question is asking for probability of x less than 5, which means is the probability of x less than equals to 4. And using the GC, you have the value as 0.994. Now, to find the most probable number, you have to use the GC. From the table, the event x equals to 1 has the highest probability of occurrence. Thus, there is most likely one defective group. And take note that most likely doesn't imply is equals to expected. From the screenshot, you need to key into the GC y1 equals to binom PDF 20, 0.06 and x, and recalling the table of values, you have seen the table of values on the right. And since you want the most probable number, you look for the one with the highest probability. And the highest probability corresponds to 0.37, and that corresponds to the value of 1.